So CNRI, Corporation for National Research Initiatives, where I've been for God knows how long. I'll give you a little history of it and a little bit about what we do now. So it was founded in 1986 as a nonprofit research and development center by a guy named Bob Kahn, with help from Vint Cerf and Keith Ungefer. So Bob and Vint are the ones who get all the awards for, quote, inventing the internet, although of course nothing is, invented by itself, but they're the co-authors of TCP/IP, which is the basis of the internet. And when you get to, and they were awarded the Turing Prize, which is the so-called Nobel Prize for computing. And when you get the Turing Award, you're supposed to give a lecture. Since there were two of them, they did an interview. And I mentioned this because of one of the things I took away from that interview, which is still out there. This is probably at least a decade ago now. Vint's very articulate, but Bob is the one who gave the takeaway that I remember most when he was asked, what was the big accomplishment here, other than the obvious? And the answer was that it was an open architecture. So you don't need to pay anyone any royalties. The internet is not owned by anyone, and the specs are open. You can read the specifications, you can build a machine, and while there has to be some control over distribution of IP addresses, it's not onerous. If you get an IP address, you can connect to the internet. And Keith Ungefer was the head of ISI, and where IANA lives, those of you who know that. So, and the goal was, and they were all associated with DARPA. Bob ran the computing office at the time. And the goal was, stated there, undertake, foster, and promote research in the public interest focused on networks. Historically, it was the past home to the IETF. NSF paid us to run the IETF before the internet had money. Then afterwards, NSF didn't have to support it anymore. The Internet Society started at CNRI. Guido van Rossum, the originator of Python, was there when Python was turned into a big deal. And DLib magazine, if any of you remember that was my job at the end. So those are all things in the past for one reason or another. So what are we doing now? Well, we have an agenda. It's called Digital Object Architecture, a set of principles and some implementations. The best known implementation of that is a handle system, which is the basis of DOIs. And I assume everybody here knows what that is at some level. Cordra, less well known, which is a server software that serves up objects. And we do development work for various organizations, including some financial groups, the entertainment industry. Every movie and TV show has a handle. You don't know it, but it's there, back in there. And surprisingly, the building industry in terms of products. And so we do that development. And we also provide network infrastructure for the DOI Foundation and for DANA, which is a Swiss foundation where some years ago we moved the handle system route. When it was clear that the handle system was going to live and prosper, it became fairly clear that a small nonprofit outside of Washington, D.C. was not the right place for it. So we worked with some others to put together a foundation in Switzerland, which has some interesting legal ramifications that it took us about 5 years to work through, but it's there now. And finally, the Microelectrical Mechanical Systems and Nanotechnology Exchange, which is of less interest to this group and is also somewhat quiescent at the moment. All right, so here's what do we spend our time doing? So this is an operational example. The other things are kind of complicated. I could go into what we do for the movie business and so on, but DOI is pretty straightforward. So I'm going to do that instead. As of the end, and we just had the face-to-face meeting, so I have these numbers handy. The DOI resolution system, which is what we're responsible for, as opposed to the various DOI metadata systems and services run by places like Crossref and DataSite. We're responsible for the back and resolution network infrastructure. It's a combination of multiple cloud services plus some co-location. That is we own some of the metal, but we use more and more cloud services as time goes on. There's 50 to 60 servers managing this system globally. It's pretty scalable. It's been built to handle a 10x increase in traffic from what it handles now. And just this year, those of you who are interested in this sort of thing, AWS now makes virtual threads available, which means we can now manage up to 80,000 requests a minute for a single process. And we have many computers that can handle that process. That sounded good. And I actually did the math this morning, and it's many hundreds of billions of transactions. So far, we don't need that, but God knows what's going to happen next. It's monitored by two different systems, one we built ourselves and one we pay for. The one we pay for was the status page thing that most people know with the IO domain name. And there are about 170,000 prefixes, which roughly, works out to 170 different organizations, 170,000 organizations, although some of those organizations are just individual journals by different publishers, although a lot of the publishers just have one prefix, and about 370 million DOIs. The big number, which is much different than our old big number, is a resolution. So we're currently on track for about 17 billion resolutions this year. That's about 1.5 billion resolutions a month. Now, again, if you do the math, there's not enough people interested in DOIs to have enough fingers for this to be human beings. So we know that a lot of it is robotic, which is fine with the DOI folks. We do sometimes have to put a governor on it when someone wants to try to resolve every DOI in the world all at once. We constrict that. It'll take you a couple of days to get them all. And if you're doing that, we'd rather you talk to us, because we have better ways to do it than to have you pound our servers. An interesting aspect of this, from my perspective, is that we could not have done this for anything like the budget that we have and the number of people we have even 10 years ago. This is, to me, an underappreciated fact, which is that developing infrastructure out on the internet today is much, much, much easier than it used to be. If you went back even a decade, if we wanted to put a new server up, we ordered the server. It showed up, in a box, and we would add chips and we would configure it, and we'd put it in the trunk of somebody's car and we'd take it somewhere. That's no longer the case. Most of this is virtual now. The reason I say 50 to 60 servers, I probably should give a bigger range, is that I can't tell you any given second how many servers there are, because they pop up virtually as the traffic requires. Yeah. So why do we care? That's sort of what we do. That's what occupies my time these days. Why do we care about RDA? What's the connection? Well, so thinking about how to show this, I took a look at the mission statements. So I've lost my slides. I did something silly.
Well, we can see them, so life is good on our side.
All right. The only problem is I can't see them.
Oh, shall I take over your presentation? I'm kidding.
No, hang on. Well,
if you want to stop sharing and pull them back up again, that's fine. It might reset everything for you.
All right, fine.
Sorry.
I'll do that.
Okay. I did that earlier today. It's kind of like, the proverbial reset of that server that's in the back of the car.
Okay. So the
All right,
problem,
there we go.
I can't get rid of your windows. There, I did it. Okay, so RDA. Develop social, organizational, and technical infrastructure needed to reduce barriers to data sharing and exchange. What about CNRI? infrastructure that can facilitate interoperability between or among different systems, processes, or other information resources. It would be funny if we didn't care about RDA, and we have been involved in it. So we participated in early organizational meetings in 2012. I established the first working group, data type registries in Göteborg in 2013. In collaboration with Peter Wittenberg, we established the TAB chairs meetings. NIST helped us do that. Those of you who went to those early ones. I was a TAB member when Francois and Andrew, I'm happy to see on the call, were leading in the glory days, and we were organizational member from the beginning. So there's a close connection to RDA, and RDA would be the sort of organization that I would really have wanted to see exist, even if it didn't. So in the few minutes I have left, I thought I'd address this digital object architecture. They, again, a set of principles with some implementation on our part, implementation by some others too. It's the idea of adding a level of abstraction to current information management systems and methods to create a set of persistently identified and uniformly addressable digital objects. The history of information management, to say nothing of computing, is one of constantly adding levels of abstraction. From not having to bring your goats to the market, instead of bringing a little token that says I have 100 goats, to the way we program computers, and now even using AI. Those of you who haven't looked at the most recent OpenAI release, 01, should take a look at it. It's another step change. It's both fascinating and something to think about. So we continue to do that. Whereas I think at some point the natural programming language is going to be English. Anyway, for basic information management tasks, as to bring up this level of abstractions, I think every object will have to have a globally unique and actionable identifier. It'll have to be typed. It'll have to have tightly associated metadata, a queryable set of operations, and a way to address it. This is for us, this is a logical extension of the internet. Remember that the real accomplishment there, the internet was not the first network at all. It was a network of networks. And the idea of a universal IP address was one of the things that made it available, a way to address every node on the network. We believe we have to start with a minimal set of components and services, identifiers and resolution system, types and type registries, object servers, aka repositories, including registries of metadata, mapping and brokering services to map existing data storage and management systems to addressable objects, and an interface. And then open the environment to as many use cases as possible. This is what's going on at the moment in the FAIR Digital Object Forum. Why is this a good idea? It simplifies the solution space. Treat every information object the same until you have to differentiate among them to accomplish your purpose. This, and push the current cacophony of information management and storage systems down a level of abstraction. There are nice parallels here as well with the internet. The core function of the internet is to move packets from one node to another. And the people, the engineers whose job it is to make that efficient, have done a really super job over the last 50 years of making this happen. But they don't care what's in the packets. So they don't have to deal, we don't have an internet for physicists and a separate internet for lawyers or doctors. We have one internet. We don't care what's in the packets until they get to the application builders. And the application builders don't have to care how the packet got there. You can make the same parallel with file systems and operating systems. So if you develop an application to run on the Apple laptop, which is what I'm looking at now, you don't have to worry about how to store the data. You just have to understand the interface of the operating system and say, here's this file, please put it away. I don't care how, and until I need it again. and the operating system hands it over to the file system, which could split it up into 100 pieces, store it on the moon, who knows, until the application asks for it again. This allows for great efficiency in development. And it means that, this is the second bullet, it means that you don't have to understand the rest of that. And that's where information management should be. We shouldn't have to understand a lot of what goes on the other side of just asking for the object and talking to it. And there's a somewhat separate issue about access control information. Currently, a lot of data, the access control, permissions, rights, and so on, is carried by the system that the data lives in. And that means that when it comes out of that system, all that information goes away.
Larry, can I encourage you to wind up? We've got one more talk to go.
Sure.
And I'm just wondering if you're close to your last slides.
This is the last slide.
Oh, snap, look at that.
And the information needs to sit with the objects. And that's it.
Oh, there it goes. One thing that jumped out of my mind and Dan's got the first question, but let me hop in right before FDO, the what it stands for just ran out of my head. This is
Fair data object.
Thank you. This is a construct that I think is really important for the OA to understand. And I wonder if sometime, maybe in 2025, we can have a talk about that. Bridget, just mental note. And if you think this is important for your organization to better understand, do pop a note in the chat so that we know that this is something we can bring back up in case you're not tuned in. If you're not tuned in, I think it's something we need to get you tuned in on. Dan, please go ahead.
Yeah, sorry, and this is a little bit of a comment that could lead into a long discussion, so I'll just make it and then we can see if it's worth actually talking about or not. So it actually is related to that comment you just made about what does FDO stand for, and somebody said fair data object, which I think is actually fair digital object, not fair data.
Yes.
And so that's, I think that's actually the point, is that all of this makes a lot of sense to me for data, but it doesn't necessarily make as much sense for other things that you might store as a set of bits, but aren't actually useful as a set of bits, but actually have to be interpreted in some way or have some action. And so, Larry, I don't remember if you were in the FDO meetings that I was kind of talking about software in, but I'll just say that I think things like software or services are things that are executable, things that act, as opposed to things that are data, don't seem to me to work so well in this model. I think the idea of having an identifier for them is great, and that makes sense, although we haven't gotten to the world in software where we have a single identifier, and instead we have 6 or 7 different kinds of identifiers that are used in different contexts. But I feel like the question about something that is acted on or something that acts as an object is not necessarily something that has been either well thought about or at least well explained in some of these examples that I've seen before.
Okay. Yeah, it's a longer conversation.
Okay.